So in this problem, we have the differential equation y prime equals x times y plus y. There's also this initial condition that when you substitute 0 into the function, the y value is 1. At first, we're supposed to draw a directional field. And so for that, what you can do is make a little table of values and say, what does x equal, what does y equal, and what does y prime equal? And we're just going to do a few of these values basically to get a little bit of an idea. So here's an analogy. So I Googled up pencil art and I found this video where this woman showed how to draw this, which is beautiful. It looks even better on the screen because I printed it out. It looks awesome. And then she said, here's where we start. So that's what she started with. This is what she ended up with. So when we draw it, it's not going to look like that. It's basically, we're just going to get a very rough sketch. Okay, so in here they say if x is 0, y is 1, so you might as well start there. So they're saying that is an actual point on the graph. And if you substitute x is 0 and y is 1, this is going to be 0 plus 1. So y prime is equal to 1. And don't forget that y prime tells you the slope of the tangent line. So if we start looking at the graph, then at the point 0, 1, then it's got a slope of 1. So it's going to be about like this. And then, let's see, this is a slope of 1, so that means if you go over by 1, you go up by 1. So if I say that x is 1 right here, and I followed this along, I would get up to this point right here. And if you go over by 1, go up by 1, that means that this is now at 2. So the next point that I'm going to do is, if x is a 1, y is a 2, and then plug that in. So this would be 1 times 2, so that's 2, and then plus another 2 means that the slope is 4. So instead of a slope of 1, then it's going to have a slope of 4. It's going to be much steeper. And then if we were to go the other direction, again, if you go over by 1, then you have to go down by 1, which would actually be right here on the x-axis. So that means x equals a -1 and y equals a 0. And in which case, if y is a 0, that's a 0 and a 0, so y prime is 0, which means that it's got a horizontal tangent line right there. So basically, so far we're getting a shape that looks something like this. Okay, so like I said, we're only to get to this part of the artwork, not being able to see the whole thing. Haha, very funny. Okay, now on to the actual math part rather than the art. I mean the art of math. So solve the actual differential equation. So with this one, I can separate the variables. So on the left, I can replace y prime with dy dx. And then on the right, I can factor out y, and it's going to leave x plus 1. All right, so first, that part's done. Next, move all the y's to the left side and all the x's to the right side. So divide both sides by y, and it's going to become dy over y. And then multiply by dx. And now all of the y's are on the left side and all the x's are on the right side. And then integrate both sides. And then hopefully you realize that on the left side, the antiderivative of 1 over y is the natural log of y. And then the antiderivative for x will be x squared over 2. The antiderivative of 1 will just be x. and then plus c. And I could then solve for y by exponentiating both sides. That's why I have a red pen. So on the left side, these cancel, so we get y equals. That's good news. And then we'll have e to the x squared over 2 plus an x plus a c. And the next thing is we have this initial condition that if you plug in that x is a 0, then y will equal 1. So if y is going to equal a 1 when x equals 0, this would be 0 plus c. So it just leaves e to the c. Now usually I would say go ahead and find out what c equals by taking natural log on both sides, but I can see in the problem it has e to the c in it, and since e to the c is so simple, it's just a 1, I would prefer to use that. So I would rewrite this function as y equals, and then basically just use the property that if you have a times or raised to an exponent, and then if you have a raised to another exponent, then you add the exponents. So usually we would go from here to here, but because it's an equation, you can go from here to here. So with this extra plus c, I can say that is e to the c times e to the x squared over 2 plus x. So I'm just factoring off this 1 e to the c and putting it in front. And then we just did this to find out that e to the c equals 1. So replace this with a 1 and we'd get e to the x squared over 2 plus x. And that is the solution. And now let's see if we graph this, does it look anything like our beautiful artwork over here? So time for the calculator, and to save some time, I went ahead and typed it into the calculator. And so I already got the